Composite materials are more difficult to machine than metals mainly because they are anisotropic, non-homogeneous, and their reinforcing fibers are very abrasive. During machining, defects are introduced into the workpiece, and tools wear rapidly. Traditional machining techniques such as drilling or sawing can be used with proper tool design and operating conditions. Non-traditional machining methods such as waterjet, laser, and ultrasonic machining are also used. All these are very briefly discussed in this video. Cutting composite materials, structures wears down cutting tools more rapidly than tools for traditional engineering materials. CNC turning is a common technique for machining carbon fiber parts in different industries. It offers predetermined dimensional tolerances on components with generally circular surfaces. The properties that make carbon and Kevlar so strong also make it difficult to cut while using a traditional wire cutter or scissors. Conventional machining processes such as turning, drilling, or milling can be applied to composite materials, provided proper tool design and operating conditions are adopted. PCD end mills work well for orthogonal cutting such as slotting, trimming, and pocketing. Sharp tools are a necessity when machining composites. Once cut, edges can be finished with light sandpaper or a file. Machining of composites is probably of greater risk than the potentially toxic chemicals. Dust and decomposition products arise. It is essential to minimize this risk by extraction at source, or entrapment in a stream of gas, air, or water. Composites are cut using various techniques including water jet cutting, which is flashed on screen. Water absorption may be an issue, especially for materials with weak fiber matrix interfaces aramid composites. Another cutting option, which involves bigger budget, is laser cutting. Basic information is flashed on screen. Laser cutting can easily process Kevlar, carbon, and glass fiber composites. Surface preparation is the first step in joining procedures of fiberglass components. Surface preparation works to ensure the best possible mechanical bonding, adhesion, or weld quality. It also helps to mitigate against later problems, such as corrosion and mechanical damage. Once the adhesive type is determined, second important step is surface preparation. Adhesive bonds are made to adhere other components to substrate surfaces. Most surfaces are covered with contaminants. If not removed, bond failure will often result. Joining processes are typically divided into three categories: mechanical fastening, welding, and adhesive bonding. All these joining methods produce good results. However, choice of the joining team depends upon the construction materials and applications of the composites product. Mechanical joining includes bolting, riveting, caulking, shrink fitting, and folding, all of which join workpieces by using mechanical energy. Metallurgical joining includes fusion welding, pressure welding, and brazing, soldering, which use different energies. In general, bonding between two composite layers is achieved in the presence of an oxygen-inhibited layer of unpolymerized resin. Epoxy adhesives are the most common adhesives for composites. Heat-curable single-component epoxies provide high-strength bonds to many composite materials. While repairing composites products, the adhesive patch, also known as bonded patch repair, becomes the main choice for repairing damaged composites. There are many types of adhesive patch repairs, such as one-sided composite patches, double-sided patches, and patches for cracks. In sandwich panels, if one face is damaged, it can be replaced with a new piece. For damaged honeycomb core, injecting a foam material is the best solution. Detailed lectures on each bonding, machining, and repairing techniques for epoxy fiber composites will be uploaded by CMB team of TE&MC in near future. Important web links are flashed on the screen. Stay tuned for more lectures and courses designed by Technical Education and Mentoring Center.